In this video, I want to talk about another relationship between line segments in a circle and the relationship between the lengths of those line segments. This one is just dealing with chords, so we call it the chord theorem. Let's take a look at a diagram. Now, I asked you to investigate this situation in GeoGebra. So we've got these two chords that intersect each other. The chords AC and BD, they intersect each other there at E. And what we're going to have by the end of this video is we're going to have a relationship between the length of these four parts of line segments. All right. So I gave you a little tip as you were poking around in GeoGebra, and that is, let's connect these extra line segments so that we have a little bit more of a butterfly picture going on inside the circle. All right. One reason we like drawing auxiliary lines like this is now we're dealing with some triangles, and triangles are something we've been doing an awful lot of proving with in our proofs up to this point. So now that we've got two triangles in this diagram, let's see if we can find relations between them, between maybe their sides and maybe their angles. So if you haven't poked around in GeoGebra yet, making a diagram like this and moving those points around, maybe assigning lengths to all of the sides and all of the angle measures so that you can see how they change as you slide the points around, then go ahead and do that. And if not, just pause the video and think about what relationship between all of these angles and sides are very clear, things that we can prove given the facts that we know up to this point in our mathematical explorations through the year. All right, well, one thing that students have popped onto pretty quickly is that these two angles right here must be congruent to each other. Let's put down statement and reason. Why don't we? All right, so this will be a little bit informal. I'm going to call these angle 1 and angle 2. So I'm going to say angle 1 is congruent to angle 2 because they are vertical angles. All right, are there other relationships between these triangles that you can notice right off the bat? Well, if you took my advice of putting these things into GeoGebra and tracking the size of angles as you slid points around, one thing you may have noticed is that these two angles are always congruent to each other. So I'm going to say angle D is congruent to angle E. Now, just noticing that, just looking at that, in noticing that that's true in GeoGebra and noticing when you drag all of the points around, it stays true, that's not a reason we can put down here. You know, I observed it in a whole bunch of different cases, is not a logically sound reason. Because there might be some case where it doesn't happen that's not quite clear to us. So we've got to come up with a better reason than that. Unfortunately, there is one in this case. Can you spot it? I'll give you a hint. It's a video that I posted a little bit earlier in this playlist. Well, let's think about angle D and angle C. These are both inscribed angles. Let's take a look at the arcs that they subtend. So if it's hard for you to spot, going from A to D to B, if it's hard for you to spot that arc, then my recommendation is you use your hands to cover up everything outside the angle. And we can see now it's pretty clear that the arc that angle subtends is the arc that goes from A to B. All right, try doing the same thing with C and see what you notice there. Well, with C, it's exactly the same arc. So those two angles both subtend arc AB. Is that enough of a reason to know that they're congruent to each other? Yes, it is. That was what we called the corollary to the inscribed angle theorem. that if two angles both subtend the same arc, this arc must be twice the measure of this arc, of this angle, and this arc must also be twice the measure of this angle. So therefore, those two angles have to be the same. All right, so that's cool. I've got one pair of angles that are congruent between these two triangles, and I've got another pair. Is that enough information for me to say something interesting about these two triangles? Yes, it is. This is the angle-angle similarity theorem. If I've got two angles, that's all I need to know to be able to say that angle AED is congruent to triangle BEC. All right, so that's kind of cool. Anytime you've got two chords that intersect each other, if you connect their endpoints like that in the opposite way, you always wind up with two triangles that are congruent to each other. In the next video, we're going to move on from this fact. So we're going to take the fact that those two triangles are similar to each other, and we're going to say, what can we say about the sides that make up that triangle based on that similar relationship?